about the forces and interaction. We've taken this lesson last year, but I'll do a quick overview on this lesson before reaching the new ideas. At first, the force is a mechanical action. We can push a box, raise a book, compress a spring using a mechanical action. The effect of a force, it deforms the body, causes motion of a body, and changes direction of a body, like striking two moving balls as the billiard ball. The characteristics of a force, since it's a vector, we can represent it by a vector. We know that we take a scale and we draw the force. Every force and every vector has four characteristics: the point of application, line of action, direction, and magnitude. The point of application is where the force starts. In case of the contact forces, the point of application is the point of contact. When the force is force acting from distance, like the weight, magnetic and electric or electrostatic, it's drawn from the center of mass, or we say the center of gravity. The line of action is one of three. It's either vertical, horizontal, or oblique. The direction is upward, downward, right, left, upward, right, and so on. The magnitude, we can calculate the weight by weight equal mass times gravity, and tension using Hooke's law, K times delta L, where K is the stiffness of the spring and delta L is the elongation or the compression of the spring. We can also calculate the forces or the magnitudes of the forces using the equilibrium of forces, the condition of equilibrium, which is called the Newton's first law. We'll mention it later. Okay. As we said, as we talked about these four characteristics. Okay, now we can classify the forces as contact and forces acting from distance. This information is from last year. Now, the new thing is the addition of forces. If we have more than one force, let's say two forces, how can we calculate the resultant force? The resultant force is the force that is equal to all forces. Okay, so the resultant of two collinear forces having the same line of the same direction is the single force of the same direction and line of action of the individual force, and having a magnitude equal to the sum of both forces. As you can see in this picture, the two persons are pushing the box. The resultant force is the summation of F1 and F2. So F resultant or F total is F1 plus F2. This is the magnitude relation. While when the two forces are opposite to each other, the resultant force, of course, is the subtraction of the two forces. Let's say F1 minus F2 or F2 minus F1. Whether it depends on whether which one has larger magnitude. So you can see the resultant force F1 minus F2. If F2 is greater, no, this is wrong. If F1 is greater than F2, and it's F2 minus F1 if F2 is greater than F1. In general, F resultant is F1 plus F2 vectors. Okay, so as a vector relation, it's always addition. But when we go to the magnitude relation, it's either subtraction or addition according to the direction of the vector. If the vector is opposite, so it will be minus. Okay. So we can also calculate the resultant force graphically by the summation of vectors, as we studied in mathematics. We can draw the palm, parallel and equal line vector, parallel and equal vector. We can draw the palm, and the diagonal is the resultant force. Similarly here, these two tension forces, the resultant force is the diagonal. This is the T resultant. This T resultant is equal to weight, so the system is all in equilibrium. Okay, so we can calculate the resultant of two forces by drawing the palm. To calculate this diagonal, the magnitude, we use the cosine law, or when the two forces are normal to each other, are perpendicular, we use the Pythagoras theorem, which is F1 squared plus F2 squared. Thank you.